I'm here today to talk to you about Hello Retail. It's the project we've been working on for some time, so I'm hugely gratified to be able to share that with you. My name is Rob Gruhl. I'm the senior manager within Nordstrom Technology of the Technology Acceleration team. So we're focused specifically and primarily on serverless patterns and architectures and how we can apply those to production problems. Hello Retail is available as a Nordstrom Technology open source project. You can find it now, github.com, Nordstrom Hello Retail. And if you do hello-retail-workshop, you'll find the self-working walkthrough of that we're going to be putting on next week within Nordstrom internally, and we hope to share it with a number of you. Nice thing about winning the Innovation Award is it's not just a crazy idea, it's now an award-winning crazy idea. So, thank you. We'll wear that coat and keep us warm for another 4 months. So, I want to say thank you to our amazing team. This is the 5 of us. We built this image for the internal Nordstrom Serverless conference that we held a couple months ago. We had 140 engineers show up, and this is our team, Eric, Reglorn, and Ashmi, and we're waving goodbye to all the old problems. And you can see Tim Wagner driving up his little truck of hopefully smaller, better problems, but it's kind of a theme within our team. We try to stay realistic, a little bit humble. So what have we done? I'm going to go through this pretty quick. So in March of 2015, as a proof of concept, with a single developer, we built a real-time stream processing system that replaced a legacy system that was responsible for showing recently and frequently viewed in shelves all across Nordstrom.com. So this experiment was highly successful. It's still in production today. It's low latency, it's extremely inexpensive, and it really kind of kicked off our passion for making this work. We then did a web service for an in-store beta. There was a team that really wanted to do a beta in the stores themselves, but the traditional ways of doing it would not have hit their timeline, so our team jumped in and was able to provide them with a web service. This again worked well, but quickly became obvious that we needed some kind of a deployment framework. So we took some time and worked with Austin and the Serverless Framework crew to do some open source contributions specifically to make sure that the serverless framework would work in an environment where you don't necessarily have all the permissions that you might have in a private account or in a startup. Then, now armed with that deployment framework, we deployed a real full-time web service to production. And then we put together Serverless Artillery. If you've never met your cloud technical account manager, a great way to meet them is to stand up a serverless web service and hit it with 50,000 transactions per second. When we gave this, this is Serverless-Artillery and Serverless-Artillery-Workshop. We gave this workshop at Serverless London and had a great time, and we knew we were successful when 2 people had their cell phones ring, and it was their account manager saying, so how's it going? What's going on? Can I help you? So this is basically just a way of taking the artillery.io NPM core built by Hasse Veldstra and the other good folks at Shoreditch Ops in London, and using serverless to create an ephemeral architecture. One Lambda might be able to handle 50 transactions per second, so if you ask it to do 50,000, well, it can just go and invoke 1,000. So super interesting stuff. We're getting a lot of traction on that. Would love your feedback. But what am I here to talk about today? I'm going to talk about Hello Retail. Hello Retail is an open source, mobile-first, 100% serverless, event-driven, functional proof of concept, showcasing a central unified log approach as applied to the retail platform space. Now, this isn't just a cheap attempt to win the Pacific Northwest buzzword bingo competition. It's actually something that we're pretty passionate about. So you've heard a little bit about central unified log, maybe event-based architectures. When you start working with serverless functions, you quickly discover that you're really looking for events. So this is maybe the logical extension of that approach, which is to say, what if the event stream were the core source of truth for your entire architecture? So instead of this bottom left-hand view over here, where you have this connected graph of all of your microservices and all the challenges that brings, we have a new set of challenges with a lovely diagram on the top left, where every microservice knows how to produce to the event stream and consume from the event stream. And I don't have the time to go into it, but luckily there are people who have. I highly recommend reading the work by Jay Krebs, Tyler Akadow, and Martin Kleppman. Our very favorite is the free ebook on the left-hand side from O'Reilly. Martin Kleppman gives a fantastic historical overview of the 6 things that came before Central Unified Log that are almost like Central Unified Log, and talks about how they're a little bit different. and maybe how we combine all of those things into one idea, which is the central unified log. Okay, I'm not going to tempt the demo gods today with a combined cell phone, website, SMS, MMS demo, so I'm going to walk you through with slides, but you on your phones right now can hit this site. So if you go to austin.hello-retail.biz, you'll log in. When you log in, you will give us your first and last name. Also, if you choose to be a photographer, you'll provide your phone number. So if you're not comfortable with any of that, Eric, Ashmi, or myself are happy to walk you through this demo. But if you want to have some fun, select merchant, make up a new product, keep it clean, please. If you want to snap a photo, you can snap a photo as a photographer or register yourself as a photographer. So let's walk through what you would see. So you log in using an authentication service. That gives you access to this. We have 3 different roles. So here, if we select the customer role, we'd see we have a variety of different product categories. You can tell we're a back-end team, not a front-end team, based on the beautiful dev art. It's an open source project. If anyone wants to make this beautiful, we would love your help. So here, if I go back to that top line navigation, I say I'm a photographer, I put in my phone number, registers me as a photographer. In this instance of the demo, we've configured it so that you're only registering to take 1 image. So after you've taken an image, you'll need to come back and register again. As a merchant, I can go in, I say I have a new product for my Hello Retail website. It's animals, they're cats, they're Airbnb brand cats. When I walked into my Airbnb yesterday, there was 2 cats that greeted me. That's quite lovely and unexpected. So that creates the product. Now as the photographer, I would get an SMS message on my phone that says, hey Rob, can you please snap a picture of cats? And then I take a picture of those cats, and I respond to the SMS message with that picture, and shortly thereafter, usually about an average of 10 seconds, it's mostly gated by the time to upload from your phone. You get a response. Now you come back and you see there's a new category called animals. There's cats available, and there's a picture of the cats. So, and then you can buy the cats. So, actually, if you're going to use the website, if you could click the buy button on whatever is of interest, it will help us. We're trying to debug an issue, so the more random purchases we get, the better. All right, so again, that's austin.hello-retail.biz. You can play with it. I hope people take a look. So real quick, the overall concept, the key concept of the central unified log, you have producers. Those are event producers. They say, I just witnessed something and I want to tell everybody. They write it to the event stream. You have consumers. Those are asynchronous, decoupled microservices that say, I'm watching the event stream for things I care about. And the consumers can do a whole bunch of different things, but maybe one thing they do is they create a view and then they put an API in front of it and a client can ask. So I'll walk you through the overall architecture. The web pages are static hosted. That's pretty straightforward, but our team hadn't had experience with that. Let's look at an example event producer. So here we have the photographer. From the client, the photographer posts to a gateway. We have a serverless function that takes that post, does input validation and schema validation, and then writes it to the stream. The key with event producers is that the event producer is fundamentally witnessing a thing that occurred in the world. It's not saying a table update happened. It's saying somebody wants to make this shirt $10 cheaper, or Rob Gruhl just walked into the serverless conference, or someone carded an item. So it's an expression of an observation, and along with that is all the relevant data that is not specific to the technical context. And the producer, importantly, has no idea what anyone's going to do with it. So an example event consumer. Here we have the merchant who's created a product that's been produced onto the stream. Now we have a serverless function which is watching that stream, and it is producing 2 different views. One of those views is a products DB and the other is a categories DB. And you can easily imagine another event consumer that's doing, say, a color analysis or a fabric swatch analysis and creating their own views. So event consumers watch for specific events. They have an at least once processing guarantee, which means you have to do idempotence correctly. And then they could create a view, they could take an action, they could even produce events back onto the stream if you had something that was enriching your data. And for those of you who know a lot about DDD, domain-driven design, you know more than I do. But from the little I know, what this allows you to do is say the events themselves are domain independent, and then each individual view can be highly domain specific. And in fact, you have the luxury, because you can build these views in parallel, of making a unique, bespoke view exactly for the problem that you're trying to solve. Here's another slightly more complex event consumer. When the merchant produces an event on the stream, we have, like over here on the far side, we've got the serverless function that kicks off a step function. This was another thing our team wanted to try out. That step function goes and looks at the available photographers and says, I found a photographer. If it doesn't, it will retry until it does find one. So this step function says, my job is to make sure that a photograph gets taken. So once it finds a photographer, it uses the serverless functions to invoke Twilio, because our risk wasn't big enough with this project, so we said, let's do Twilio, right? Twilio sends you an SMS. When you respond to that SMS, it goes back through a serverless function. The image gets put into an object store, and then it informs the step function that it successfully completed. The step function then acts as an event producer and produces an event onto the stream saying, a new photo is available for this product. Our product catalog microservice says, I'm also interested in new photos, and when I see one of those come across the event stream, I'm going to update my product detail table. So this is basically the complexity of that step function. There's some interesting things going on here, if you want to talk about that later. Okay, so when you put it all together, we have a photographer registered with the system, and a microservice that recorded that photographer into an available photographers table. The merchant described a new product that we want to make available in the Hello Retail system. We have a microservice that picked that up, updated that category page, and updated the products database. At the same time, we had another consumer that said, when I see a new product come across, I'm going to kick off this photographer step function to make sure that we get a photo of everything that's on the site. And then we have this consumer purchasing cats. And then the final thing is just these traditional request response interfaces on the front. So one interesting thing here is, to most of your users, you have this traditional request response on the front and the back. So it doesn't look too different from what they might expect. The difference comes from the fact that you can extend the system in some interesting ways, and I'll get to that. All right, so it looks a little bit busy maybe, but really the majority of it is configuration. So the great tradition of my team is to spend a whole lot of time writing a very small amount of code, and this really follows that tradition. A producer Lambda, including input validation and schema validation, is less than 100 lines of code. So when you do this right, it's very easy to add a new producer. It's very easy to add a new consumer. The step function itself might be, I don't know, 100 lines of step function definition. So when I show people this demo, you know, there's some people who are like, oh my gosh, that's amazing. There's some people who are like, so what? I can do that already. Why is this interesting? So some of the benefits, it's easy to add completely new functionality. In the workshop, what we walk people through is creating a winners microservice. And what that means is, who is the merchant that sold the most and who is the photographer that sold the most? And all of that information is available on the stream. You don't have to modify any of your existing microservices or views. You don't have to treat a database as source of truth and go and convince that team to add something. You can just watch the event stream, keep track of the creators, look at by events, increment a winners table, and then put a microservice in front of that. You can run multiple versions of the same service in parallel. So if you decided you wanted product catalog v2, you can run that in parallel with product catalog v1. You can do an A/B experiment across those two, and if you like version 2 better, you just throw away v1. You don't have to migrate the data from that catalog. Your analytics systems watch real events. They're not watching some secondary telemetry stream which is inevitably incorrect. So I think this one's pretty profound. Your analytics system is watching for purchase events on the stream because those are the events that are the purchases. So you get very clean data, potentially. I'm sure there's plenty of new ways to mess that up. It's pretty quick. The latency that we experience is mostly staleness of the data. So the request response interfaces that I showed are still very quick. A typical serverless version of that in our implementation would be like 45 milliseconds P50 and maybe 115 milliseconds P99. But the entire round trip might be a half a second or a full second. But that just means your views are a little bit delayed. And then this one's pretty key, multi-cloud provider capable. When your source of truth is a guaranteed order append-only log, you can replicate that log into another cloud provider. and then you can build consumers in that other cloud. And maybe somewhere there's some poly-cloud provider event log ring that just makes it all the same, but it's not there yet. A big part of our motivation was to get dumb and understand what we didn't know. So here's some of the challenges we've identified so far. Schema registry and schema validation is a thing. We're looking at Confluence schema registry. That's primarily used in the Kafka world, but it's pretty good. It also takes advantage of Apache Avro. Poison pill data can block a stream, so if you're not handling error data well, then that challenge is compounded by the fact that it's multi-shard. So you have to figure out which shard is blocked and why. Handling PII on the stream, we do access control this using identity access management. However, what we'd like to do is give as many people access to the stream as possible, and what this means is if there's sensitive data on the stream, we want to encrypt that sensitive data. There's some fan-out read limitations. Debugging is hard. The fact that you've completely decoupled the system is fantastic until you say, I produced an event on the stream and nothing happened. So what happens next? Event stream discovery and authorization. So if you think about as a developer, I'm a developer, I come to Nordstrom and I say, oh, here's these 30 public APIs that I can use. I'd also like a view where I could see, here's 20 event streams that I can also take advantage of. And what's the contract there? Is it a schema definition? How do I authorize access to that? There's some interesting problems. And then if you're depending on order guarantees, which you probably think you don't need, but probably do need from our experience, maintaining those order guarantees across the entire system can be very challenging. So what's next? Our team is shipping a feature to production using this pattern in code. We're also looking into Kafka and Confluent. Maybe there's a happy land where Kafka and Kinesis can work together. And that's it. If your passion is serverless, and I'm guessing you're here because it is, we are of course hiring. We'd also love to hear from you. Here's a list of all the links that I talked about. We hope you get a chance to play with the Hello Retail system and give us feedback or maybe contribute to the open source projects. Thanks.